Hello everybody, welcome to this new tutorial. So we'll create something like this, something very abstract like a bunch of donuts forming the letters A, B, C and so on. So you can use it on anything, like you don't need to have it on text. It can be patterns. Basically we are going to see how to blend this RBD simulation to form different kind of patterns. First let's put down a font mode and should be A, and I'm going to transform it to make sure it is on the ground. Yeah, but I'm going to make sure that it has enough points at this on the corners. I can use the subdivide, or even a resample should work, I think, properly. Okay. Yeah, this should do, or we can have a bit more resolution, like 400 to 500 points, maybe. Like, yeah, like 400 points should be enough, I think. Now let's copy this, and here it will be B, and then C. Uh, don't worry about this filling of this hole. It should be not a problem because we are only going to use the points, and then C and D. Put on a switch. Basically, we are going to shift from one to another every 100th frame. So what you can do is you can use $F. So this is like a simple trick into 0.01, basically 1 divided by 100, because we are going to shift it every 100th frame. Okay, so now what happens is, so this will give a decimal value. What, how can I show this to you? So okay, like now imagine it's 5 into 0.01 will be 0.005. So now imagine it is like 99. So into 0.01 will be 0.99. So it is kind of less than, it is all less than 1, right? We can just floor it. Floor means it will take the lower integer value. So 0.9 will take 0.0, and 1.2, if it will take 1. So now what happens is every 100th frame we are going to shift it. Okay. Yeah. B, C, and let's increase the frame range, and D. We'll put on a null and call it out fonts. All right. Now we'll create the RBD. We'll keep it simple. I'll create a box and increase the size like 2.3 and points from volume. I need like 300 points maximum, so 0.5 or 0.3, yeah, 343 should be good. And I'm going to keep it a bit above the ground. Put on a torus. And I'm not going to change anything at all here, and copy 2 points. Okay. Okay, we do need to change the size. 0.16 I think worked fine for me. Yeah, something like this. Okay, you can keep initially wherever you want. I am just explaining it, the basic concept, and now we can assemble it so that each and every donut becomes a separate piece, and we will be able to use it in RBD. Yeah, we have packed primitives, so make sure to pack the primitives here. And now RBD solver. Okay, now we should have this donuts falling. We don't have the ground. Let's add ground. And yeah, they behave like a rigid body. That's it. Now we can dive in and put down a geometry node, sorry, geometry wrangle, and we are going to connect it to this pre-solve. And we need to bring in the fonts, so just copy this, and in the inputs, in the second input, we can import this. I'm not going to disturb the input one. It takes us as 0, input 1, input 0. So I'm just going to give it in input 2. And so I need to actually so for example, we have like 300 and something donuts. These donuts should choose one of these points randomly, and it will get pulled towards that point. So that is the entire concept. So basically we need to know how many points we have, because at every character will have different amount of point. Now 416 maybe, B will have maybe 497, so it's not constant at all. So let's uh, dive in. Basically, we are going to create a range of values between 0 and the number of points in the font. Okay, I'll call it I at num pts is equal to, or else something else. I think numpt or pts is like a default attribute in Houdini. Num fonts. Okay, we can get the number of points from the second input using n points. Instead of 0, we are going to use a value 1. So this will give how many points we have in the font. For example, A, currently it is in A. Maybe let's check if it is in fact giving it. Let's come out and put down a null. I'm going to change it to technical. You have this geometric spreadsheet here. It is very useful. And search for num something. We are not transferring the attribute. That is because in the output we need to give this attribute. It will be called let's copy the name num fonts and just paste it here. Now we'll have the attribute. So 416 points, and if you check here, the fonts will have like 416 points, but we need to subtract 1 because point numbers start from 0. That's it. But now we need to multiply this one with a random value into rand at pt num. We'll add a seed, something like 1 2 3 4 or something. So basically why we are doing this is like this will generate a value between 0 and 1. So multiplying this with 0 to 1 value will create a range of value from 0 to 400 and whatever it was. Now you see it's all different. Basically we have chosen different points for the points, and like we already have like most of the things that we want. Now we'll see how to move these points towards the these points. One more thing, you see this error, that is because this is a float value. We'll just put floor again here to make it integer, and we have a proper integer value. Now let's try to move the points towards the selected point. Basically every point now has this one value, some random point number value. We can easily move it v at p dot x. So we are not going to move the entire position, only the x and z we are going to move. Y we are going to let it perform naturally with all the RBD influence, like with proper bounds and everything. So lerp v at p dot x. So this one we are going to sorry, capital P. We are going to lerp between the x position the of the donut with the x position of these points. So we need to extract the position of these points. So for now I'm going to comment this, and I'm going to call it v at new pose is equal to point from first input. We're going to get the position, but the point numbers are going to be I at num fonts. That's it. And v at p dot x is equal to lerp. Now we have the x value. We can get the x value from here. V at new pose dot x, comma. Okay, now this third value, it's the amount, like how much we are going to blend from the current position to the x position of the font. So but this blending will happen every frame. You don't need to give a value of 1. Okay, let's see what happens when you give a value of 1. It's going to immediately, it's going to be very fast basically. Okay, we'll copy this and we'll do the same for z also. P dot z, p dot z, and new post dot z, and let's see what happens. Okay, now if you see closely, it already has this shape of A, and it was very instant, like within one frame this blending happened. And I think this font is like very small, so we'll come over here and increase the font size, like we'll transform and transform maybe 10. Yeah, now we'll see what happens. It will instantly move to the point number. Yeah, definitely this is not what we want, but instead we can give a smaller value. So each and every frame it is going to keep on blending the small value to the new position. Like for example, let's say we'll put a value like 0.02, and here also 0. This is actually very small, but we are going to try. Now let's play. So this transition is happening, but you see it's like very slow, but eventually it is going to reach the, okay, it doesn't even have enough time. Already the font is changing from A to B, and now B is going to form. Okay, so this is not what we want, so we'll choose a value like 0.1. Now let's see what happens. Yeah, we have some kind of natural behavior, and we have proper transition also. This actually looks fine. Okay, I felt that this changing the collision from convex hull to concave helps, but I'm just not sure exactly. Let's see. So you can experiment with this. I didn't do much experiment with this one. Yeah, we have the interaction and we have the transition. Hmm. If you see from side, you can see even the this donuts jumping and everything. I was like increasing the. Give me a second. Yeah, this density I increased to like 10,000. I was having some dramatic uh, bouncing. So when they collide with higher density, it was creating some good bounces. Yeah. So you see, yeah, I think I had a better bounce. We'll increase the bounce from here and here also. Now let's see. Yeah. All right. Okay. Now we'll see how to play with colors. Like we'll see how to overall like play with different colors, introducing colors and everything. We'll go in. Let's put on another geometry wrangle now. We'll call it coloring. So what I'm going to do is I'm going to choose like 4 or 5 colors. I already have this. So for example, and we are going to store these colors in an array. Okay, we'll vector. We are going to call it color. Yeah, color. And we need to give this brackets. And then we can give some colors like this. Okay, we can give multiple colors. For example, 0, sorry, 1 comma 0 comma 0 will create red, and 0 comma 1 comma 0 will create green, and so on. But actually I have some colors chosen already. I'm just going to copy it, and I have it in my second monitor, and I'm going to just paste it here. So these are like 6 colors I got. So one, two, three, four, five, 6. Okay, so you can select your own colors, and then so randomly we need to select this one of these colors. Okay, like we will choose a random frame. At random frame, random colors will be assigned to these donuts. So int, we'll call it rando is equal to, so 0 1 2 3 4 5. So that is how the number index goes. So when you're reading it from array, it starts with 0, then 1 2 3 4 5. So we need to create randomly numbers between 0 and 5. So this is another technique. So create a random value based on ptnum plus frame, so that this randomization will also be based on frame, and also you can add some seeds like for 45 anything it can be, and I'm going to multiply it by 6. So what will happen is we'll make sure that this value is like between 0 and 6. It is not going to be exactly 6 at all, mostly, because the value will be like 0 0.0 or 0 0.9999, but mostly not 1. Okay, like in the random value. So we are going to multiply it with 6, and then we are going to floor it. So now we will get a value between 0 and 5, and we can access this one like v at cd is equal to color, and here we can give this random. I think we need to transfer the color also for it to be visible. CD. Okay. Now let's see what happens. Okay. You can see like already it is taking some different color. But it is changing every frame. So we will do one thing. We will only run this or this randomly. Okay. Like for example, if rand at ptnum plus at frame, now we'll give another seed, sorry, capital F plus 88 maybe. If it is greater than 0.99, then we will do this. So basically now it is going to take some time for the colors to get applied because this condition should be satisfied. Now you can see randomly it turns to some color. Let me come out. Yeah. Okay. So we have some random colors chosen. But what I want is I want the colors to slowly change to bluish color. But I want these colors to be introduced randomly. Okay. So what we will do is v at cd is equal to, again we are going to do this same lerp. So the first value will be set 0 comma green value I'll give like 0.5 maybe, and blue value will be 1. Okay. And the second value will be v at cd. Okay, it should be inverted. V at cd comma blue color, and every frame I'm going to blend like 10%. Now what you will see is every frame we are going to, this donuts will try to become blue color, but in between there are like multiple colors being introduced, and it slowly, even if the colors are introduced, it slowly transforms to blue. And one thing we can do is this red color, I'm just going to rand at ptnum plus some seed value. Now we'll have a variety of color because this red color is like randomly applied to the donuts. Okay. Now we'll do one more thing also, like in between we'll introduce color yellow randomly. Okay. So just before here, if rand at ptnum plus, let's say, so the important thing is to give some other seed, 987 is greater than 0.99, v at cd is equal to set 1 comma 1 comma 0. So for the yellow color. Okay. Now randomly yellow color should be introduced, and that too will slowly transition to the color that is a mixture of this red and blue. You see, we have introduced some yellow colors, but I don't see them transitioning to the color. Let's see what happened. Okay, we didn't give frame at all. So that means every frame this yellow color is being applied. Okay, so plus at frame. Now this yellow color will be applied based on frame randomness too. Yeah, some are getting this yellow color, but I think this yellow color might be like too much. I'm going to reduce it. 999. So this will reduce the amount introduced more. Yeah, so here and there are like some yellow being introduced. But we'll do one thing, we'll increase it more, like 993. Yeah, now we have some enough yellows introduced. But eventually they also turn to this red and blue mixture. So I hope this tutorial was like useful for you in some way, and I will see you all in the next tutorial. But I have some interesting courses, like for example this pedestrian course, like that will follow all the signals properly. It is a crowd course, and we have this drawing course. I'll create this drawing robot that will draw anything that you give in a vector format, and to the render we will do it procedurally, and also this cloud course. So if you are interested, you can check this out. I'll give the link in the description. Thank you.